name is Keerthana, Assistant Professor, Department of Computer Science and Engineering, St. Joseph Institute of Technology. Today we will be discussing about an important algorithm in machine learning, that is linear regression. So before getting into the core concepts of linear regression, I could like to brush up the basic concept of what is machine learning, what are the learning approaches that is involved in the machine learning, and what are the types of data we will be handling in machine learning, and then get into the core concept of linear regression algorithm. So the today's agenda will be basics of machine learning. Next, we will be discussing what are the learning approaches that is available in the machine learning. Next, what are the algorithms or tasks that is coming under individual learning approaches. Next, what are the type of data that is available in machine learning, and next we will come into the linear regression algorithm. So whenever we learn a concept, we must be clear about we must be able to answer three important W type of question, like what, why we are using it, and how it is working or how it is being used in the real world. So we will be discussing these three type of questions regarding this linear regression. So before getting into this, we will discuss the basic concepts of ML. So getting into the basics of ML, machine learning, we have a basic definition of machine learning is that making the machines to learn without programming it explicitly. So what is the term without programming it explicitly means is that, suppose I need to add two numbers. What we do in a normal programming languages, we declare two variables based on the input data. If it is integer, we will be declaring it as int a comma b. If it is a float, we will be declaring it as float a comma b. So based on the input data that is given, we will declare the variable. Then next we will add the two variables and store it in a third variable. So this is the structured format for programmatic format for adding two variables. But here in machine learning, we will be not creating any program explicitly, but the machine has to learn. So how is it possible? Yes, it is possible in machine learning. The machines learns themselves through the data, through the input data. We will be giving few data, so machines will be learning the patterns in the data. So this learning of data, they technically in machine learning, they call it as experience. So with the experience, why they call it as experience is that nowadays when there is a fire burning, we know we shouldn't go near the fire, we will get burnt. So how we get this knowledge? From small age they could have trained us. If it is a fire, you should not go near the fire, you should not keep hand in the fire, you will get burnt. So based on this experience, our brain will be trained that if a fire, it will get burned. If it is water, it will feel chill. So similarly, machines also, when we are giving the input data, it will learn the patterns in the data and it will gain some experience. Now it is having the experience through the input data. Based on this data, they will do the task that is specified by the user. The task, that is many tasks that is available in the machine learning, that only will come under learning approaches and algorithm, that we will see later. Okay. So now I have my input data. So based on this data, they are going to do some task, and once the task is completed, the performance will be measured. So why we need to measure the performance? Because I need to know whether my model has learned well properly the data. And now after analyzing the performance, we will get two condition outcome of this performance. One, it will be good model, either it will be bad model. Suppose if the performance of the model is good, what we do? We just save the model. Suppose if the performance of the model is bad, what we do? We have to go back and do some alterations. So when we go back and do some alterations, where we have to concentrate to do some alterations? We cannot touch the input, that is the data. We cannot touch the task, it is the important algorithm. So we cannot either disturb the data or the task. So where we have to do alteration is that we have to do the alteration in the intermediate, which is the learning. learning part of the machine learning. So we have to concentrate how the machine learn, how it learns the pattern. For this I could like to give a real time example. Now a student is studying for an exam. Even though he studies very hard, a day he studies for 5 to 6 hours, but is not able to score good mark. What the teacher will do? The teacher will sit along with the students. They will observe the learning pattern of the students where he makes mistake and they will correct it. The same pattern is going to be followed here. So if the model is not performing well, a good data analyst or data scientist or the MList, they have to go back to the learning and they have to check where the model is making mistake in learning, and there they have to correct it. Okay, this is the general flow and this is the basics of machine learning. Now next we'll switch over to the learning approaches of the machine learning. Hope you got a clear understanding on the basics of machine learning. Next we will see the learning approaches that is available in the machine learning. In machine learning we have a basic 4 types of learning approaches. The first one is supervised learning. Second one is unsupervised learning. Third one is semi-supervised learning. And the fourth one is reinforcement learning. Okay, so first supervised learning. Supervised learning, I could like to give a real time example what supervised learning is that. When we are studying 10th and 12th standard, what a school teacher could have done, they could have given a question bank to us. In that it will contain a question and set of answers, keywords relevant to that questions. So we could have well trained on that question bank. When we attend the board exam, when there is a question addressed, we could relate that question to the questions asked. We have trained on the question bank and we will be able to answer it. So same pattern it is being followed in the supervised learning approach. What happens is that when we are giving input to the model, it will be having an output for that specific type of input. Suppose if I am having input like 1, 2, 3, this will be the output. So for this type of pattern of data, this will be the output. So this we call it as labeled data. So when I am giving an input to the model in terms of labeled data, there is a set of features, I am going to give output corresponding to the features. So when the features are like this, it is this is the output. Even giving more general example, suppose if animal is having fins, it is able to swim in the water. If it is having all these attributes, then it is called as fish. If an animal is climbing the tree, it is black fur, then it is called as bear. So with the following attributes, I am able to give the output during the training itself, then it is called as supervised data. That output to the specific attribute is called as labeled data. So when I am giving input to the model in terms of labeled data, that is called as supervised learning. So when my input contains labeled data, then it is called as supervised learning. In supervised learning, we have 2 types of tasks to do. One is regression and another one is classification. This is the task that is available in this specific learning approach. So in regression we have many algorithms. To complete this regression task we have many algorithms. Similarly to complete the classification task we have many algorithms. Not to get deeper, but to be more generic, I will just tell what are the types of algorithm that is available in regression. We have simple regression, multiple regression, polynomial regression, nomial regression. So in regression, to complete the regression task, we have simple regression, multiple regression and polynomial regression. These are the algorithms available. Similarly, for classification task, we have few algorithms like logistic regression, decision tree, KNN and then SVM. Among these algorithms that is available in classification, decision tree can be used for both regression and classification also. Okay, hope now you could have got a clear view on what is supervised learning, what is labeled data, what is the regression task, and what is classification task, what are the algorithms available in regression to complete this task, what are the algorithms that is available in classification to complete this task. Next we will get into the unsupervised learning. So unsupervised learning is just opposite to the supervised learning. In supervised learning, the input when we give, it is a labeled data. So in unsupervised learning, it will be unlabeled data. There will be giving only input attributes. It will not contain any output for that particular features or attribute. The model has to learn itself. So what is the task that is available in unsupervised learning is that clustering. Clustering is that based on some real time example, I am giving a bag full of toys to a kid and asking him to segregate the toys into two sections. What one kid will do, he could segregate according to the size. Small toys he could group into one and big toys he could group into another. Now I am giving a group of students to a class teacher and asking the class teacher to separate the class into three segments, three groups. What the class teacher could do, one teacher, she could segregate it based on gender, or she could segregate it based on some CGPA, or based on day scholar, staying near the college, hostel. So each person's perspective differs when grouping the data. Similarly, in clustering also we have different models which groups the input data based on some attributes or their perspective. So to complete this clustering task, we have few algorithms present in machine learning. The algorithms are k-means, agglomerative, and hierarchical clustering. So these are the algorithms that is available to complete the clustering task. Next, coming to semi-supervised learning. Semi-supervised learning is that it is a combination of supervised and unsupervised learning. So how the input data will be is that it will contain very few labeled data and more unlabeled data. So the input given to semi-supervised learning will be combination of both labeled and unlabeled data. The model must be able to learn from the labeled data and it must be able to work it out on the unlabeled data. The task that is available in the semi-supervised learning is that image segmentation. Segmenting the image based on the background and foreground. This is one of the tasks that is available in the semi-supervised learning algorithms. Next, coming to reinforcement algorithm. So reinforcement algorithm is that we all could have come across at least once in this type of reinforcement algorithm. We could have played some games in computer where when we didn't get a persons to play, we could play against the computer. So how they could have trained the computer is that during the training, if the computer gives a correct move, they could give a reward for the computer. Reward in the sense in terms of point. If the computer plays wrongly, they could punish the computer or the model. Punishments, they could give negative points. So the model learns that if it is getting a positive credit, that we are going in a right direction. If it is getting negative rewards, it could learn that we are going in a wrong direction. So based on this only, they have developed the automatic car driving, VR models and all. So this in a reinforcement learning approach, one of the major tasks that is used is GAN, Generative Adversarial Network. This is the type of task that is available in the reinforcement algorithm. Now, I know the learning approaches that is available in the ML and what are the tasks that is individually present in all the learning approaches and what algorithms I am using for completing this particular task. Okay. To recap quick, regression is that predicting a variable, predicting something based on the statistical data. Classification is that identifying this or that, whether it falls under class 1, class 2, class 3. Clustering is that grouping of data. A semi-supervised task is that segmenting the images based on the foreground and background. Reinforcement is that it will not be having any input data. The model has to generate the data and learn by itself. The best example task is that GAN, Generative Adversarial Network. Now I could like to give you a question. Just think for a second and try to answer what type of learning approach is suitable for this question. Okay, so identify the customer based on the shopping pattern. This is the question. So what type of learning approach is best suitable for this? Just think a minute. So my question was identifying the customer based on the shopping pattern. So what type of learning approach could best suitable for this? If your answer is supervised learning, well and good. If you have thought that it is unsupervised learning, I will justify why it is supervised learning. Firstly, we have to identify the customer. Identify the customer. Based on what we have to identify? Based on the shopping pattern. So when it is shopping pattern, we could have the data like what type of dresses they could select, for how much amount they could purchase, the frequency of visit. So we could get this data. We could be having this data readily available in the shop. So based on this, we could be able to analyze whether the persons, when they will visit the shop next. Okay. So this is supervised learning because based on these attributes I am having the output. So if they are taking this type of dresses, if they are taking western wear, they are spending this much amount of time, they are visiting weekly once or monthly twice, then again they will be visiting in this frequency of time. So this is the labeled data. This is the labeled data. For this particular type of features I am having this label. So this is a supervised learning. Now next you could have a doubt in supervised learning whether it will fall under regression or classification. Just think a minute whether it comes under regression or classification. Okay, now I will let you know whether it is in regression or classification. To know whether my task is regression or classification, to have a deeper understanding, I must be able to have a deeper understanding on the data. Without knowing the type of data, I will be not able to address the problem in real world. As a good data scientist or data machine learning analyst, you must be able to handle the data well so that you can address the real world problems. Now we will see about the data that is available in the machine learning. So in data, basic type of data we have two. One is numeric. We all know that it depends upon the number. Next is text. So text in ML we are taking it as categorical or category, anything. Okay. So this is the major two subdivisions of data that is available in the machine learning. So in numeric again we have two types. The first one is continuous data, second one is discrete data. So what is continuous data is that I am having a number 1, 2, 3. Okay, this is a whole number. Suppose if I am able to have infinite number between these two numbers, then it is called as continuous number. What is infinite number between two numbers is that between 1 and 2 I can have infinite numbers like 001, 1.002, 1.01. I can have like infinite numbers between these two numbers alone. So this type of numbers, it falls under continuous number. I will give an example of what and all comes under continuous number. First, when a person asks what is a weight, what could we say? Like 65.75 kg. When he asks your height, what could we say? 11.5 inches. When they ask what is the quantity of water that is present in the can, we could say 12.75 liters. So when it comes in decimal, we call this type of data as continuous data in machine learning. Next, discrete data. What is discrete data is that it is the whole numbers like 1, 2, 75, 1000, The example is that when a person is asking how many students are present in a class, we could give a whole number like 60 students are present, 30 students are present. We couldn't say 35.7 students are present, 30.2 students are present. We could never give that answer. So when it is a whole number, we call that as discrete data in machine learning. When it is in decimal number, we could say that as continuous data in machine learning. So these two types of data comes under the numeric data. Next, coming to categorical. So what is categorical in the sense? Categories of data. So categories of data in the sense, taking the blood group. What are the types of blood group we have? A positive, A negative, B positive, O positive. And next, educational qualification. What all we have? 10th, 12th, UG, PG, PhD, PDF, etc. Okay. So again, similar like numeric where we have two categories, in categorical also we have two categories. So one is ordinal, another one is nominal. So what is ordinal in the sense? This both examples suits for categorical. Here in these two example, will I be able to order my data? See, we'll take education qualification. Will I be able to order it? Yes. First they have to complete 10th, then 12th, UG, PG, PhD. This is the order. I can order my category. Even though it is a category, I can order it. So this type of data come under ordinal data. Here you take the blood group, I cannot order it, I cannot give O positive is the first, A plus is A positive is second, A negative is third. I cannot order this data. So this comes under nominal. It can be of any order. So even though it is categorical, if I am not able to order those categories, then it is called as nominal data. The categories of data where I am able to order it, then it is called as ordinal data. Now I have a deeper understanding on type of data. What is numeric data? In numeric, what I could call it as discontinuous data and what I could call it as discrete data. In categorical, what is ordinal data and what is nominal data. Now when if I for the previous problem statement, identifying the customer based on their shopping pattern, I have identified that it is a supervised learning approach. So what type of task it has to do, whether it has to do regression or classification. Now based on this data, I will be able to identify whether it is going to do regression task or classification task. If output of my problem statement is going to be numeric, then it will fall under regression task. If output of my problem statement is going to be some category, then it is going to be classification task. Suppose in the above asked problem statement, identifying the customer, if I am going to identify how many customers are going to come next week, then it is a regression, because how many customers, it is going to give a number output. So it will address that as a regression problem. Suppose if I am going to take it whether this particular customer will come next week or not, then it is a category type. That type of problem statement will be addressing it into categorical type. So we must have a clear understanding of the data, and then secondly we must know the problem statement. What is the output of the problem statement, whether it is going to be numeric or categorical. Then based on that we can approach it as a regression task or classification task. Suppose if it is not having any labeled data, then we can directly address it as a clustering problem where we have unsupervised learning approach. Okay. Next, now we have a clear understanding on what is the basic of ML, what are the learning approaches that are available in the machine learning, along with the task that is given in each learning approach, what algorithms is applicable to complete each individual task, and next what is the data. Now we will get into the core concept of linear regression, which is the basic and important algorithm in the machine learning. So what is the term linear regression means? Just have a think over it. So linear regression is, we could have all studied in our school itself. linear regression. For any concept we study, we must have a basic meaning about the naming convention of the topic. So linear, we all know linear is something like this straight line which consists of slope. Next, what is regression? Regression has the meaning that it denotes the relationship between the dependent variable and independent variable. So regression is that relationship between dependent variable and independent variable. So you all now have a doubt, what is dependent variable, what is independent variable? I will give you one example. Suppose I am having a input data like has studied, marks scored. Suppose a student is studying 3 hours, he is getting 50 marks. Next, if he is studying for 5 hours, he is getting 60 marks. He is studying for 10 hours, he is getting 90 marks. So this is my input, consider this as my input. Here the hours he is studying is independent variable, it is not dependent on any other features. Now this marks scored, this it is dependent on this particular feature. So the mark he obtained is dependent on the hours he study. If he study 3 hours, he will get 50 marks. If he study 5 hours, he will get 60 marks. So the output is based on some input. So now this we call it as dependent variable and this we call it as independent variable. Okay. Now showing the relationship between the dependent variable and independent variable in terms of linearity, you call it as linear regression. What is linearity? So I am having a graph like this, I am plotting this data. So consider this as the x-axis, y. My independent variable will be always in the x-axis and my dependent variable will be in the y-axis. I am having plotting this 10. Okay, for 3 what I am getting? 50. For 5 what I will be getting? 60 somewhere around here, and for 10 I am getting 90. Keep it somewhere around here. So I am able to join all these points so that I could get a line. So this says that there is a linear relationship between the independent variable and the dependent variable. That is, the output is either increasing or decreasing with respect to the input. So this we call it as a linear regression. I hope now you got a clear understanding on the naming of the topic linear regression. Now we will get into the concept. Hope I have answered this. What is linear regression? So why we need linear regression is that when we have natural calamities like rainfall, tsunami and the wind blow, the weather forecasting we could have displayed that the amount of rainfall registered will be so and so, the amount of tsunami registered will be so and so. So how are they predicting this amount? It is based on the statistical data. They'll plot all those older statistical data and they'll form a linear line regarding this, and when given a new year, suppose they have plotted data for last 10 years, they have plotted all this data. Now I need to identify it for a new year like 2007 what it was. So here by using this they could identify what is the amount that has been registered in 2007. So this we call it as a linear regression, predicting something in terms based on the statistical data is called as linear regression. Okay. So here how it works is that I could like to tell the algorithm of linear regression. In step 1, first we will be taking the input. Consider the earlier example where I have given hours, marks. This is x and this is y. Okay. So we have to first take the input. Input x is equal to, here unfortunately we have taken only one input, but when we deal with the real world problems we could have n number of inputs, like starting from x1 up to xn. This n may be even thousands also. Okay, then we'll be having the output for that. So whatever the input is there, we could first consider take the input. Second step is that we have to create a hypothesis. What does the term hypothesis defines is that based on our assumption we are creating a equation. Since it is linear regression, we have to create a line equation. What is the line equation which we studied in our basics class? Y is equal to mx plus c. This is the line equation. So based on this we are going to create an hypothesis. So my input y prediction is that m is that weight of this particular input plus one bias. So why do we need weight for this particular input? I could tell you with an example. Suppose I am going to cook a biryani. Spices, salt, rice, let's have main ingredient. Okay, 2 grams, 5 grams. Okay, we could discuss the algorithm steps that is available in the linear regression. In step 1, first we have to take the input x. In real world problem we could get many input features. So that's why I have marked as x1 up to xn. This n defines the number of features in my data set. Second step is to create a hypothesis. Create a hypothesis. So hypothesis is that it is not a conformed equation or conformed model's weight. We are creating a weight or we are creating an equation based on our assumption. So here I am creating a hypothesis. That is why I have mentioned it as y prediction, which is equal to, since it is a linear regression, we are going to use the line equation which we studied in our smaller standards, like y is equal to mx plus c. So based on this line equation we are going to create a hypothesis for our machine learning linear regression model. So we are going to create a weight for this specific input. This is the weightage given to this particular attribute up to wn xn plus bias. Why do we need add bias to this particular equation is that when we handle real world data, we don't get pure data. There will be some noise and errors in this particular model. So to make the model learn the errors during the training itself, we are adding the bias. So next, step 3, we have to initialize this weight and bias to some random variable. Initialize the weights w and bias b to some random variable. This random variable, random number should always be a smaller number, like for example 0.1. Next, step 4. We all know that while we are learning the basics of machine learning, what we have done? We have given the input data to do some task and then we have measured its performance. Here my input is x. The task is to do the prediction. Then performance. I have to evaluate my model now. So I am calculating the error. In linear regression, we have two types of error. One is the mean square error and another one is mean absolute error. Okay. So why we are taking either squared or absolute error is that I could like to give an example. Suppose we are having a data like x. This is my input, this is my y and this is my prediction, and here I am going to calculate my error 3, 5, 10, 15. and my y prediction is minus 5, and here I am getting plus 5. So now I am going to calculate my error. When I add this error, what happens is that this plus 5 and minus 5 cancel out and it becomes 0, so that my model learns that there is no error in the learning of the model. So no, it has minus 5 error and plus 5 error. So if we add it directly, it tends to give 0, and the model might mug up that there is no error in the learning. So that's why we are either taking square or absolute to convert the negative values into the positive values. That's why in calculating the error, it is being as mean sum squared error or mean absolute error. Now we have calculated the error. If the error is pretty minimum, then we could say this is a good model and we could save this model. If we have got a big, the error rate is very high, what could we do? We should optimize my error. Apply the optimization. So what is optimization is that reducing the error is called as optimization. In optimizing, I have 3 types of optimization technique available in my machine learning. One is stochastic gradient, second one is mini batch, and third one is batch gradient. So stochastic gradient is that I am going to take a single data point and update the weight and bias. Mini batch is that, consider I am having 100 data points in my data sets. I am going to split this 100 data points into some n numbers like 10, or I am going to split it into 5 data points. So splitting a heavy or large data set into fewer data points and then updating the weights and bias for those particular data points. Batch gradient is that considering all the 100 data points at a single time and working on the updations of weight and bias. So this is the 3 types of optimization that is available to reduce the error. Once we have optimized, what we could do finally is that we could calculate the accuracy and save the model. So this is the flow or algorithm of linear regression. First we will be taking the input, next we will be creating a hypothesis. While creating a hypothesis, we have to declare the weight and bias to a random number, which is very small number like 0.1. Next we have to calculate our error, which is either a mean squared error or mean absolute error. Next, if the error is very high in number, we have to go for optimization technique. We have a basic 3 optimization technique available in machine learning, which is stochastic gradient, mini batch gradient and batch gradient. So once we have reduced the error, we have to calculate the accuracy and save our model. This is the algorithmic approach of the linear regression. Thank you. Now I will give few questions and try to answer what will be the correct learning approach for these questions. Okay. So first one, you are given a large data set of handwritten images and asked to identify which is true image, which is false image. So what type of learning approach is this? We have studied supervised, unsupervised, semi-supervised and reinforcement. They are given a large data set of handwritten images, and in this we have to identify which is true image and which is false image. So just think of what type of learning approach we can handle this. It comes under supervised learning approach. In supervised learning approach, it comes under classification task, because I have true or false, whether it falls under true category or false category. Second question is that I have given a group, a few set of features like age of a person, income, number of persons in his family. Based on these features, you are asked to group the customer. Then what type of learning approach or task we have to address for this question? We have to do clustering, which is unsupervised learning approach. Why? Because grouping, when we have to group it, it comes under clustering. Here it is classification. And third question, I have given you a task to develop a AI agent, an artificial intelligence agent to play a video game. So what type of learning approach is this? It is reinforcement learning. When you come across the words like agent, rewards, this type of words, you could surely tell it is a reinforcement learning approach. And the last question is that I will give you 4 choices, and then you have to identify what are the choices falls under classification approach, what are the choices falls under regression approach. First one, you have to predict a email is spam or not. Second, you have to predict the score of a team. Third, you have to analyze the language of a document. And fourth one, you have to identify the number of persons who will visit the mall. So you have to, from these 4 choices, you have to identify which all comes under regression and which all comes under classification. Now first let's go into predict email spam or not. Don't fall for these words like predict, classify, analyze and all. Only for grouping we can surely tell it as clustering. Only when it comes for agent and rewards, you can tell it as reinforcement learning approach. Here when it comes to classification and prediction, it might be little confusing, so we have to analyze. Here I have to analyze whether it is spam or not. So it is category. So this comes under classification. Next, to predict the score of the team. What is the output of this score of the team? It is a number data. So it is prediction, which is regression. Next, analyzing the language of a document, whether it is English, Tamil, Telugu, Urdu. So it also comes under category. So it is classification task. Next, identifying the number of persons who will visit the mall. So here the output is number based. So this is also prediction. I hope you have got a clear understanding about the basics of ML and the learning approaches and the datas. Thank you for watching the video.